Okay, now in this video I'm going to represent you what is Autotransformer. So in my previous videos, I think there was 15 videos in this course, we used a single phase transformer with the primary winding on the secondary winding, and they are insulated by the core, and the energy was transferred due to electromagnetic induction in that ferromagnetic material. Now, this is a special type of transformer that is commonly used in industry, especially when you are starting the induction motor. Okay, now an autotransformer is a transformer with only one winding. Also, in a single phase transformer, you can reconnect it to be autotransformer. I'll show you that. First, here is the schematic of an autotransformer. Now, you would say that these two are separate windings, but directional. Oh, just a second here. Okay. Now, if you have a winding and it's wounded or a coil and it's wounded on some kind of ferromagnetic material, then the induced voltage from here to here would be the voltage that we brought from the AC supply. That is V1, and it has a number of turns N1. But if we put some kind of put some kind of windings, for example, on the zero reference voltage, and anywhere here on the middle, and there is going to be an induced voltage that is equal to V2. Now, the same formulas govern in the autotransformer as well in the single phase transformer. The N1 divided by N2 is going to be V1 divided by V2. If, for example, this was a slider and you can move it down and up, then the voltage V2 will go from 0 to V1 if you have this kind of connection, and this is called the step down autotransformer. You can use a step up autotransformer, but it's the more commonly used autotransformer is the step down. But I'll show you the step up also. Okay, so you can put it anywhere, I2, and V2 is going to change if you are changing the position of this terminal over here. Okay, now, what are the formulas? Well, the magnetomotive force on the upper half of the autotransformer is equal to N1 minus N2 times I1. You know that N2 is equal to N1 divided by A, the turns ratio. So this here is equal to 1 minus 1 divided by A times N1 I1. So that is the magnetomotive force in the upper half of the autotransformer. The magnetomotive force on the lower side is equal to N2 times I2 minus I1. Why I2 minus I1? If you connect a load over here, this current here is going to go like this, here, and by Kirchhoff's law, this is going to be I2 minus I1, looking at this or node over here. So the current in the lower half of the autotransformer is I2 minus I1. And you know that N2 is equal to N1 divided by A, or the turns ratio times I2 minus I1. Okay, by Ampere's law, which you learned in fundamentals of electrical engineering, physics, and in my course of magnetic circuits, of course, if you watched my course, before learning electrical machines, you have to know the course of or the lecture of magnetic circuits. You know in this situation that the magnetomotive force on the upper half of the autotransformer must be equal to the lower half of the magnetomotive force of the transformer, and this here is going to be equal to this. So you have this formula over here. Okay, and of course, if you have current I2, if you have a lower voltage than on the secondary, then you will draw more current than on the I1. So literally every formula stands here. So remember, autotransformer is a single phase winding, and also the same formulas govern over here. However, if you had an autotransformer like this, for example, and we brought the primary voltage to this lower half of the autotransformer, and we put the terminals on the secondary here and here, then this is a step up voltage, because if you have a ferromagnetic material, you would have the same flux that goes in this ferromagnetic material, and more the winding you have, then you have more winding here than here, obtained here on the secondary than on the primary, then the voltage is going to be higher. But if you draw some current over here, then the current is going to be lower on the secondary than on the primary. Also the same equations govern over here. Okay, now this is for the autotransformer. What are the benefits of an autotransformer? You can the internal impedance is lower in practice. I just forgot. Yeah, less core is needed than in ferromagnetic material than in a single phase transformer, and higher power can be obtained. You will see in my next video, when we do an example, you will see that the higher power can be obtained. You can transfer a lot more power in an autotransformer than in a transformer, but it's not only magnetical transformation of energy. There is also galvanic. As you can see over here, there is no insulation, so if you touch this, it is most likely going to burn you. Okay, now this was autotransformer, only had one winding. Now I have to show you how you can reconnect a single phase transformer into an autotransformer. Okay, so for a single phase transformer, you had a primary winding and you had a secondary. Let's call the terminals capital A and capital B on the primary, and small letter A and small letter B on the secondary. Now if you do something like this, then basically and let's say this is the number of turns P, or number of turns of primary, number turns on secondary. Basically, what you did when you connected B with small letter A is this. Now this is the NP and this is the NS, and now you can bring the terminal, you can bring however you want this to the terminal. For example, you can bring the primary voltage like this, and the secondary voltage you can bring like this if you want to step down the voltage. If you want to step up the voltage, then you can do something like this. So here is V1 and V2, and that is it. So I hope that I explained a little bit about an autotransformer like in this video, but in my next video I'm going to do an example, so watch my next video and you will learn a lot more about autotransformers. See you in my next video.